Hello, everybody. My name is Carter Burke. I'm with Exceltex. I'm the antenna guy. And I want to thank Keith. You put these presentations nicely that actually lead right into mine. With David was talking about all the bandwidth and IoT and then interference. And anybody here, a lot of you guys are the experts in the industry. Your network is only as good as your antennas. So if you don't have a good antenna, you're going to have problems. So I'm going to talk a little bit about the importance of proper antenna selection in high density applications. More from an external antenna perspective, nothing wrong with integrated antennas, but obviously for this, I'm going to talk about external antenna options. So we talk about high density or very high density. I'm from South Texas. I know y'all may not realize that from me talking, but I want to make sure we clear up, again, David was talking about, something that's high density, then very high density. So I'm going to clear it up for y'all so y'all know how we define it in Texas. This is defined as not high density, and that's very high density. So now that you guys are cleared up. So what's the problem with high density? Why is the antenna selection important? It's kind of funny. Back in the old days, and Keith, you remember this, they'd always say, we're going to put an antenna in the center, and how much does it cover? Turn on 100 milliwatts and go. Now it's changed. It's a lot of different challenges. One of them is the growing bandwidth requirements. Again, I'll go back to David's presentation because he said it. What's happening today in IoT is going to be different in 6 months, a year. So the bandwidth requirements today are going to get more and more, so it's making the high density environments even more challenging. Crowded areas with lots of people, that's kind of obvious. Potential obstructions. Nicholas, you were talking about your high density application that you're working on in your stadium. That's going to have bandwidth requirements, obstructions, lots of people. So we have to figure out how we use the people to our advantage. It can be a challenge, but it can also be helpful in high density. Non-Wi-Fi interference, we had a whole section on that, you guys know that. But one of the biggest things is focusing the RF energy. We always talk about covering where you want to cover, but not covering where you don't want to cover. That's probably the most important. Because if you're covering, way past your target area, you're going to bring in more of those interferences. We'll talk a little bit about that. So common type of antennas, I feel pretty comfortable you guys know how antennas work and things of that nature. So obviously you're directional and omnidirectional. When you're getting in high density environments though, what you tend to want to stay away from is any of these real high gain omni antennas, mainly because it's going to cover too big a footprint. And when you're in a high density environment, you're going to really usually want smaller footprint, smaller coverage area to make smaller cells. So there's nothing wrong with using omnis in high density environments, but normally it's going to be your smaller ones. Where we're spending most of our time and where we're seeing most of our really R&D going in from us as a company is directional antennas for high density. Because we're trying to not only cover smaller areas, maybe go further distances sometimes like in stadium applications, but just making sure we're minimizing our interference by only covering the areas we want to cover. So it's very important. And one of the things, and I did bring an antenna up here, one of the things very important in high density, and really any directional antenna, is your mount. I don't know if you guys have seen a lot of different mounting solutions, but a lot of times we would always say when you're surveying, assume you're not installing. Because you go out, and if you don't have a good mounting bracket that has good, like degree dials that you can dial it in, where you can tell an installer, I want it 30 degrees, to the left and, 30 degree down tilt, what you may have happen, which I've had a troubleshooting where I went in and it was installed on the wall like this, and they weren't having coverage. What's wrong? The installer didn't know. He just put it up, and that's the way it came out of the box. So you want to make sure you have it set up right. Another thing we've been investing a lot in, I don't know if you guys have heard, and you'll probably have, of dual polarity antennas. Really, the way really before MIMO, most of the antennas were vertically polarized, which means, I got a picture here. Think of vertically almost like, that's a Loch Ness monster for you British guys, but it's not, it's supposed to be a serpent, but think of a sine wave going like this. That's normally the vertical polarization. What we do in dual polarization is we have elements in here that are going like this, but then we also turn them at a 90 and make them horizontal. So think of a snake. And so what you end up doing is you end up getting a picture where, and you guys can come look at it, where you have different elements. You have elements that are horizontally polarized right here. Actually the element sideways, it's actually vertically polarized. The actual circuit board is horizontal, and this one is going vertical, but the elements are actually horizontal. But what it allows you to do, because in MIMO where you're sitting and receiving simultaneously, it allows you to actually minimize the collisions. And if you can minimize the collisions, it's going to make for a more efficient network. And this is actually where we're seeing a lot of our R&D going into this, because it's allowing us to really do more with the antenna, do more with the access points. So you see a lot of these, depending on the number of leads, is really going to depend on what kind of radio you're using. This is designed for a specific one. We have some with 3 leads and things like that, depending on what you're trying to do. Anyway, so, and one thing, again, on the back, which is kind of nice, is it'll tell you which one's vertical and which one's horizontal. So when you're putting it in on your access point, it allows you to know which one is going to go to which port. Here's my contact information. I actually went shorter than what I thought. So if anybody has any questions, if not, I can talk to you guys later. Okay.